All right, good afternoon, everyone. I'd like to welcome you to the February webinar for the Lake States Fire Science Consortium. I'm Jack McGowan-Stinsky, and I'll be moderating the webinar this afternoon. For those who may be joining us for the first time, I want to give you just a little background. We are funded by the Joint Fire Science Program and are one of 15 regional consortia for fire science exchanges across the country. Our mission is to accelerate the awareness, understanding, adoption, and sharing of wildland fire science information by federal, tribal, state, local, and private stakeholders across the Lake States and the adjacent Canadian provinces of Ontario and Manitoba. We strive to be inclusive and neutral science partners working to foster collaboration among researchers and practitioners and organizations and individuals, and by developing innovative approaches to science delivery while facilitating dialogue about new science findings and emerging needs. Before we get started on the webinar, I want to just take a few seconds and look at our Adobe Connect webinar interface. To ask a question or interact with the attendees, please use the chat box, which should be located in the lower right-hand portion of your screen. Once you type the question, make sure you click the send button so that we can see it. We'll be monitoring these questions, and we'll make sure that there's an opportunity to address them. If you'd like to learn more about the consortium and what we are doing, please visit our website at lakestatesfireside.net. You can sign up to receive our newsletters and announcements, and you can also follow us on Twitter and Facebook. Now let's get into today's webinar, Common Denominators for Escape Prescribed Fires in the Lake States. Steve Goldman has been an employee of the U.S. Forest Service for 25 years. He currently serves as an Assistant Director for Fire and Aviation Management for the Eastern Region, with emphasis on the Fields Program. Steve also served on the Coronado National Forest in Arizona for 9 years, the Cherokee National Forest in Tennessee for 4 years, and as a District Ranger on the here in Manistee National Forest, Mile Ranger District for 11 years. Steve graduated from the University of Arizona with a BS in Renewable Resources in 1993. Steve is currently qualified as a Type 2 Incident Commander and a Type 2 Burn Boss with 25 years of firefighting experience. And he's also the primary author of the Mack Lake Staff Ride. So with that, let's get to the webinar. Take it away, Steve.
All right, thank you, Jack. Appreciate it. And we'll go ahead and get right into this. So I just want to give a disclaimer first. Everything that we're presenting here is meant to help us develop high reliability organizations in whatever organization you all work with in relation to prescribed fire. The escape prescribed burns that are being discussed were all implemented by talented, highly motivated, well-intended professionals just like us. And just like us, people make mistakes. It's 100% certain, and we need layered defenses and good planning to defeat that very fact. So we're going to talk about that as we go through this, and we're going to see some of the common denominators that have occurred decade after decade, and see what we can do to use that for the future. Okay, topics to be covered. We're going to talk just a little bit about high reliability organization characteristics. We're going to take a look at national escaped prescribed fire statistics. And then we're going to look at the lake states in general for common denominators and also a few examples in the eastern area that are not in the lake states. We're going to take a look at situational learning tools to help reduce the risk of escape or other undesired outcomes. We're going to use the Mack Lake Staff Ride and the Foss Lake Facilitated Learning Analysis as examples of that. And we're also going to take a look briefly at tips for pre-mortems during our prescribed fire planning. So we're going to cover a lot, and so I'm going to take you over the treetops. It's about 500 feet, and hopefully there's some information that will help you in your programs. A quote that I've always liked is, there are no new accidents, just the same accidents happening to a different individual or a different organization or a different time. Certainly new things can happen, but as you'll see in these common denominators, it's really many of the same things happening over and over, just different places, different times, different organizations. Okay. We're going to use the Swiss cheese model as we go through this and talk about a trajectory of how certain things, whether they're active failures or latent conditions, can breach our defenses and essentially create holes in the Swiss cheese that if those line up, we're going to end up with an unintended outcome, and in this case, prescribed fire escape and the consequences that come with those escapes. Okay, high reliability organizations. Some of you may have heard of this, some maybe not. Airline industry is one example of a high reliability organization. We'll take a look at an example of that here in a minute. But there's 5 main attributes for these types of organizations. They preoccupy with failure. They identify and respond quickly to things that aren't going right. They don't ignore them or assume that, well, that's just part of our normal business. These organizations also have a reluctance to simplify. They like diverse perspectives and input to assure they're not missing something. There's a sensitivity to operations that these type of organizations exhibit. And that means as an operation is occurring, if something changes, they react to that. And that leads into the 4th characteristic, which is a commitment to resiliency. And there's decisive response and adaptation to unexpected developments. And I think our fire organizations are very good at that. And then there's a deference to expertise. It's not what position you have in the organization, it's what you know. And the folks who know the most about something, no matter who they are, what position they normally sit in, a high reliability organization will listen to them. Okay, high reliability organization planning is what separates our prescribed fire operations from a typical wildfire. In prescribed fire, we predict and select the weather, the site locations and fuel conditions. We pick the timing of the prescribed fire. We select what resources and how many of them will be on the line. We pick the control features in fire lines. So we control almost everything except possibly the most important thing, the fact that everything is involved with people, and people are imperfect. So we have to develop ways in our organizations to manage the fact that we're not always going to make the right decision or perform an operation correctly every time. But an example of a high reliability organization is the U.S. commercial air industry. And I want to start with, there is one aviation accident on here where we lost 50 people. And, that's an amazing loss of life. And so I'm going to leave it at that and talk about the good thing of these statistics. But you've got 60 billion flight miles over 8 years in one fatal accident. So when you look at this industry, 76 million departures, 141 million flight hours, over 8 years and only one plane went down, causing fatalities. That's an incredible track record, and there's tremendous complexity to what those airlines are doing, but it is possible. And I'll give an example of it. How many have sat in an airport and they're not going to launch the plane because they're missing one steward or stewardess? You would think, that's no big deal. I want to get to where I'm going. Let's take off with just one stewardess instead of 2. They won't do it. And that's because they understand the risks they're involved in. So let's move on to prescribed fire, some national statistics. From 2003 to 2007, we had 55 escapes throughout the U.S. Forest Service. 25% of those occurred during ignition, and the majority occurred well after the next day. Some of the issues that came about in those burns were burning into worsening weather, and we have examples of that in our Lake States area that we're going to look at. Inadequate staffing for the duration of the burn. There just weren't enough people there long enough to hold it. Failure to follow the prescribed fire plan. If you can't follow the plan, it's best to stop, not continue. Unexpected weather, very common factor in escapes here locally and nationally. When you go to the period 2008 to 2013 nationally, there were 50 escapes. And again, the majority of those escapes happened after the ignition day in the mop-up phase, although the percentages are a little bit closer to 50-50 on this. 40% of the escapes occurred during the ignition process on those fires. And that is different from the Great Lakes area, and we'll talk about that. The recurring factors on those escapes, new fuel types. There were drought effects that caught folks by surprise. Unexpected changes in weather or changes occurring more rapidly than expected. Piles holding heat longer than expected, or landscape scale burns in multi-day operations. That adds a complexity that caused some problems. So when you look at the trends nationally within the U.S. Forest Service over about a 20-year period, from 96 to 2001, we were losing on average 39 fires a year, but we were holding 99% of our prescribed fires. You know, that would seem on the surface a pretty good number. But if you look at an airline industry, if only 99% of their flights were successful, where would they be? Going from 2003 to 2007, a significant improvement. We were only averaging about 10 escaped fires per year nationally, and we're starting to near 100% numerically on our effectiveness. And from 2008 to 2014, again, we improved, and we were averaging only 6 escapes per year at a 99.87% success rate. So pretty good numbers in a good trend. Okay, as you take a look at this from a graphical standpoint, you can see the number of escapes per 1,000 prescribed fires over the years. And, you know, you've got a pretty good trend going downwards in terms of the number of escapes. So a good trend, and it appears we're going the right way, but we're certainly still having escapes every year. You know, if you look back to that aviation data that we saw, it would be great to see only every few years maybe we'll have an escape in the agency. So, okay, so let's talk about some of the fires that occurred in the Great Lakes. There's 10 fires here. 2 of them are not in the Great Lakes. One's out of Missouri, and another one is Pennsylvania State. And I do want to make a clarification. The one for Pennsylvania State is not an escape. It's an injury fire where there was a serious burn injury. So I did choose to include it, and it just happened this past spring, so I felt it was relevant. But when we take a look at these fires, starting from the left and moving right, all of them are small. 8 of these 10 are below 100 acres, and most of them are significantly below 100 acres. They're small prescribed burns. And when you start to look at what fuel they're in, most of these burns were grass for the fuel type, also light slash, some brush. So you start to see some patterns, small burns, grass and slash component. As we move across this table, the fuels that those escape fires got into, about half of them are jack pine, which for the Lake States is one of our most volatile fuels. But you'll see they also got into hardwoods and blowdown and mixed conifer. So a variety of fuels that were affected once these came out of their burn units. When you look at when these fires were implemented, the majority of them were implemented from late April all the way through May. So there's really a 4 to 5 week period where most of these escapes occur in the Great Lakes. Again, the 2 examples from Pennsylvania and Missouri are slightly earlier in the spring due to the different fire seasons. So just have to consider that. Ignition time. If you look on this table, most of the escapes, the ignition is occurring between, say, 10:30 in the morning up until about noon. And the time of escape is happening shortly thereafter, from noon to about 2 in the afternoon for the majority of these burns. And one of the common factors we talked about nationally was burning into a window that is going out of prescription. And that's what you're seeing here. And we'll talk about that a little bit more. From a relative humidity standpoint, 8 out of 10 of these burns were in, the humidity was in the 20% range. So you got a real consistent common denominator there. As you get below 30% humidity, you start to have fire behavior that is going to be very difficult to control. And as we talk about the Swiss cheese model, you got fire behavior that's difficult to control, and other factors start to play in, you're going to have your hands full. The 2 fires that had humidities above 30% both got hit with some type of wind event or other failure. So, and that leads us to the next column, which is equipment failures or accidents. 5 of these escapes can partially be attributed to equipment failures, engines, pumps, vehicle accidents that change the amount of resources we have to control the fire behavior we're dealing with. So very important factor there and common. When you talk about the fire behavior, almost all of these fires were, they had frequent and somewhat profuse spotting that eventually caused the loss of control, or there was a wind event, or both combined. And you see that in the notes there. And then the final column is days since measurable rain. And a lot of the reports didn't have the data, so I listed it where I could find it. But you know, you have anywhere from 36 hours to 7 days since rain. So the days since rain in the Great Lakes area and the eastern area is very important. 1 or 2 days difference of drying can make the difference between whether you can hold a fire or not. And anything that has a D next to it indicates drought. So 5 of these 10 all had drought of some type in place before the ignitions occurred. So you kind of see those factors lining up. Some of the consequences of this, the Mack Lake Fire went 24,000 acres in an afternoon. We had 1 citizen injured, our dozer operator, James Swiderski. He was fatally injured on the fire. We lost 44 structures, and of course, non-agency lands were burned, damage to our reputation. And the burnover of our dozer operators considered an entrapment. So of these 10 burns, you've got 3 that resulted in entrapments. You have 4 that resulted in injuries. The 3 injuries on the Missouri fire were heat-related with those folks trying to catch that fire. So some pretty serious consequences. Even if no one's hurt, injured, there's no entrapments or structure loss, you can see that obviously there's a damage to any agency or person's reputation if a fire escapes, because the public looks at us and has that trust in us. So some pretty significant consequences for these types of events. So the lake states compared to the national data, I think the biggest thing is we suffer the same types of common denominators, but we do it in a little bit different way. The Great Lakes, most of our escapes happen right during ignition, and the minority of them happen afterwards in the mop-up stage, typically when high winds and dry weather combine to push smoldering heat out of the burn unit. Where on the other side, nationally, most of the escapes really are in the mop-up stage, and the minority of them are occurring in the ignition stage. So there is a difference there. Okay, so we're just going to look at a common denominator trajectory for escape prescribed fires. You can see the Swiss cheese there and the holes in it. And you start out up at the top right there, and move my cursor. And you have grass fuels. You might not have best fire line location, and we're going to talk about that. You have pressure to want to implement your burn, and that's one of the factors that comes up in the reports. And you may have some drought in existence. Try to ignite that burn at noon under low humidity, maybe at the bottom end of your prescription. And as you do that, of course, since you're right around noon, you're getting the wind shifts and wind gusts start because of the daytime heating, and you end up with some spot fires and slop overs. Nothing unusual about that. There's probably quite a few folks on this call that have been in that situation. But then we'll throw one more curveball at you. As you're trying to deal with those spot fires and slop overs, your Type 6 engine breaks down. And all of a sudden, here in just a matter of 2 hours, you've gone from what should be a pretty standard day to fire running through grass that can't be stopped because your primary suppression tool on that side of the burn has failed, and you have an escape. So it's not a hard scenario to see, and in fact, most of the 10 fires we just looked at had that scenario in some form or another. Okay, talked about compromised control lines. The report from the 1980 Mack Lake Fire said we need to use the principles of fire behavior as a basis for locating control lines. And what they found was they felt that the control line was placed in an indefensible position due to some of the aesthetic lead strips of timber that were left in the design of that project. And flash forward all the way to 2016, the firefighter that was burned and spent 7 days in a burn center in Pittsburgh, they identified that they really should have used a nearby road to hold that burn. It would have made the burn more effective. And we'll talk again about 2016, the Foss Lake Fire, excuse me, on the Superior. Same type of finding was that the FLA team felt that what the folks on the forest were saying was that, you know, there were some constraints on that project that made the burn block more difficult to implement than it needed to be. And they felt that was one of the factors, and I would have to concur with that. Okay, so common denominators for prescribed fire escapes in the lake states. Try to break it into two separate areas, and the first one is fuels and weather. And grass, slash, and jack pine are all significant contributors to some of these escapes, or a majority of them. Relative humidity below 30%, and the resulting very low fine dead fuel moisture, and the high probability of ignitions that occur, especially as your sun angle is high because you're starting early in the late morning, early afternoon. You end up getting conditions drier and higher winds than expected. That's one of the factors. Too many days since last measurable rain and or mop-up stage, you get some very dry, windy conditions. So those are some of the common denominators on the fuels and weather side. More on the human factor side, we tend to plan small fires, prescribed fires, and we end up having equipment failures or accidents. We also, as fire managers and personnel, it's common that we underestimate the fire behavior at low relative humidity. And then you couple that with late April through May prescribed fire ignitions. That's right at the height of our fire season in the Great Lakes. Another factor is poor fire line location and design. The burn boss can only do what they're handed. So if we hand them a good project and a strong design, that puts them ahead of the curve. And if we do the opposite, it puts them behind the power curve. Our ignitions are occurring late morning to lunchtime. That's a human factor. I'll leave that to you all to figure that one out. I have my own opinions. There's an internal pressure to achieve, and that's been highlighted in a number of the escape reports on the burns that we just looked at. We have a job to do and we want to do it. So we have a bias for action. And that's good most of the time. And I'll emphasize the word most there. And we tend to burn on the hot side of the prescription sometimes. And the weather we're getting on site versus weather that's being taken off site with maybe more accurate equipment can put us right on the edge of whether we're in prescription or not. Okay, so given all that, how do we improve? Since it's clear that some of the same things catch us from year to year or decade to decade in almost any portion of the country, how do we continue that graph that we saw earlier of reducing the number of escapes that we have and the other unintended consequences that can be tragic? And I think one of the biggest tools we have is post-mortems, and we're going to go through a couple of those today in the form of staff rides. We'll look at the Mack Lake Staff Ride real quick. Facilitative learning analyses. We'll look at the Foss Lake FLA. And rapid lesson sharing, near misses, or after action reviews. All those are post-mortems that we can learn from previous events. But maybe even more important, and I think the agencies have a lot of work to do to define how we do this, but pre-mortems. And that's taking a look at a project in the pre-decisional planning stage and really finding ways to tear it apart and pressure test it and see if it's actually going to work. And so we do that in the planning stage and after the decision's been made, but before we implement, to essentially run post-mortems on it to see if we can make it fail. Okay, staff rides are about leadership. They were started by the Prussian Army in the early 19th century, and the U.S. Army and U.S. Marine Corps adopted staff rides in the 1970s, and they're considered essential instructional techniques in advanced military schools for developing leaders and how they make decisions, and looking backward on historical events and learning about how those people in those times made decisions is very important in developing us as leaders today. So staff rides were developed to study historical events. They're usually run by a cadre of trained facilitators who know that event. And the intent is to put you in the shoes of the decision makers of the people at that time. So we'll look at May 5th, 1980 for the Mack Lake Fire today. It's not a tactical fault-finding exercise. It's more to help you learn how you would deal with those situations in the future, because at some point we're going to be put in challenging situations, and how will we deal with them. And there's just a few questions listed below that kind of poke at a person's leadership skills as you go through a staff ride. So the Mack Lake Staff Ride. It's a leadership training program that walks you through the events of the Mack Lake Fire on May 5th, 1980. It's currently under revision, but it is still out there. You can go through the current version, but we are revising it, and it will also include the 2012 Little Mack Lake Fire and also the 2014 Maple Ridge Prescribed Fire, which we will look at today. Those latter two are both success stories. So this staff ride will take you through numerous events. Takes about 6 hours in the field if you want to invest the time in it, and the Huron-Manistee National Forest is the host, and if you contact them, they will help you run through that staff ride. This staff ride is one of 12 national staff rides, and you can see the website there that you can take a look at those. The only other prescribed fire that escaped that's part of those 12 is Cerro Grande, and for those who don't know, that's a fire that went into Los Alamos back in the year 2000. That was an escape prescribed fire. So one other source, many staff rides that are created now and into the future, they will be put on the Lessons Learned website, and you can see the website link there. So a couple different sources to take a look if you want to go through staff rides. So the Mack Lake Fire, May 5th, 1980. 11 men, 1 tractor plow, 1 heavy engine, and 1 light engine set out to accomplish a prescribed fire in the morning before an approaching cold front. So they were trying to beat the weather. Okay, it was not the Mack Lake Fire. It was the Crane Lake Prescribed Fire, and it was supposed to be 28 acres of grass and light slash immediately west of Highway 33. Their prescription was to be, temperature had to be greater than 45 degrees. Wind direction west, please remember that. Wind speed 5 to 10 degrees or 5 to 10 miles an hour. Day since measurable rain 2 to 5. Please remember the 5 number there. And relative humidity 25 to 50%. Again, you see that bottom range of their prescription in the 20s. Okay, so here is some of the weather for that area. And if you take a look, the last measurable rain was on April 29th, and the Mack Lake Prescribed Fire, or the Crane Lake Prescribed Fire, was ignited on May 5th. So by my count, that's 6 days without rain. The prescription said 5. A lot of people would say, just like a stewardess on an airplane, well, we don't need 2 stewardesses, we can go with 1. Well, the airline won't lift the plane. Well, here, if the prescription said 5 days, should you light on the 6th day without rain? So, Crane Lake becomes a Mack Lake Fire, and the plan was, cold front was predicted to arrive in the afternoon, so they were going to go out at 9 in the morning, get the prescribed fire started, get it done probably well before noon, before their prescription window closed, and be ready to fight any fires later that day. So they felt it would be no problem getting that burn done in the morning. What really happened was they didn't get the burn ignited till 10:26 in the morning. They got repeated spot fires once they lit that burn in between their control line and Highway 33. One of the two engines that they had, a Type 7 engine, stalled and got stuck and had to be assisted by the dozer twice, which took the dozer away from suppression activities. And of course, the engine couldn't help. And by 12:30, the fire had spotted across the main highway and had escaped. Okay, so we're going to talk a little bit about control line. Like I said, we control what we do before these prescribed fires happen. So where we locate our control line is a big factor. And you can see the south, southwest, and western control lines were a dirt road. So they had pretty strong control lines right here. But the east line was a tractor plow, which is not a very wide line for those who know that type of equipment. And they wanted a west wind. So they had a west wind putting pressure on their east line, their weakest line. They had their wind prescribed to go against it. And you can see they had timber left here and timber left here in between their line and the highway. So when the fire started to jump all along their highway, it was jumping into a fuel type that, if it got going, could produce a lot of firebrands, and in fact that's what it did. And the fire eventually jumped across the highway and started moving to the east under a west wind. Okay, so again, using that Swiss cheese model for the Mack Lake escape, some of these are probably familiar to you all if you've been out implementing prescribed burns, but probably not all of them have happened to you at once. But this is what happened on May 5th, 1980. They were probably out of prescription. They had pressure to complete that burn. It was part of the accident report. They had an approach in front. Their east fire line was fairly weak. It wasn't a good fire line. And their prescribed wind was from the west, which would pressure that east fire line. They got a late start. They didn't get their burn initiated till 10:26 in the morning, and they started to get numerous spots. They started to get smoke affecting Highway 33 because that's where their prescribed wind was pushing the smoke. And then they had trouble with their Type 7 engine. Again, equipment failure and breakdown. And by the time all that added up, by 12:15, less than 2 hours later, the fire had spotted across Highway 33. And what you have is all the holes in the Swiss cheese are there. And it didn't take long, and you have a prescribed fire escaping at that point. And for this fire, one of the big questions is, how do you react? Because, you know, the escape fire was one thing. Of course, the other consequences that occurred after that were much more severe. Within the hour, the fire became a killer. This is an eerie picture for me. This is my old ranger district, and we had many large fires after this one during my tenure. But you're looking at a killer. It released the energy of 9 Hiroshima atomic bombs on its way to burning 24,000 acres, but more importantly, we lost Jim Swiderski and a whole bunch of structures in the Mack Lake subdivision. So this webinar, you're really looking at the reason for it. The most important resource out on these burns is us, the public. And so there's some pretty significant consequences if our defenses get breached and holes in the Swiss cheese form. Okay, so that's all fine and dandy. You know, we know we can look back at all these burns and see some of the common denominators. So how do we make sure it doesn't happen in the future? I don't know the complete answer to that. I don't know if anyone does, but I'll just give you one sample. And it's called the 2014 Maple Ridge prescribed fire. What we chose to do in the Mack Lake area was to do some reverse engineering. We took the factors from the 1980 Mack Lake fire that we felt were relevant that caused some of the escape. We said, we're going to do the opposite. And so we didn't light the fire at 10:30 in the morning for this prescribed fire. We lit it we started it at 7 o'clock at night. We didn't use a small tractor plow line. We used fuel breaks and recent fire scars to control the fire behavior, much stronger control features. We ignited the fire right adjacent to the subdivision. We didn't light it several miles away. We lit it right on top of the subdivision, which meant if the fire had any problems, it had no fuel to run at the subdivision. We didn't wait for 6 days after the rain stopped. We lit it 2 days after rain. And we also didn't, we wanted to be in a position where the burn window was collapsing. So on the Mack Lake Fire, RH was 37% when they started that prescribed fire at 10:26 in the morning, and the humidity rapidly dropped into the 20s and stayed there all day, as well as winds increasing and probability of ignition on that Mack Lake Fire rising to estimated around 90%, which essentially is a mass ignition problem at that point. For the Maple Ridge Fire, the humidity was 31% when we started, and it climbed rapidly throughout the ignition phase. So the weather was getting cooler, wetter, with calmer winds, and a probability of ignition that was only around 40% and dropping. Okay, we'll take a look at the burn area for this. And as you can see, there's the prescribed burn unit in the middle. It's a square-shaped unit. And then you've got fuel breaks on the east side in the subdivision, and you've got you can see the crown fire scars from the 2012 Little Mack Lake Fire. And then there's a swamp and some aspen units on the southern side of the burn right there. So there's your fuel break. This is your burn unit right here for the Maple Ridge burn. And then the 2012 Wildfire scar through here. All right, looking at the rainfall that occurred prior to that, the spikes on this graph are the individual rainfall events, and then the stair-step line is the accumulation of rain. And the net result of that was we had 1 inch of rain over 7 days in multiple events throughout that week before this prescribed fire was ignited. So essentially, we were wet when we lit this prescribed fire, and the intention was to light crown fire. But what we were looking for was not an expanding burn window, but a burn window that was collapsing. So if you look at the chart here, our humidity during the time of ignition dropped by 20 percentage points from 28% down to, get my marker going here, went from 28% to 48%, and our temperature dropped from 76 degrees to 67, and our winds dropped from 8 miles an hour to 3 miles an hour. So Mother Nature was going to shut this burn down if we didn't, and that was the whole design, was to have that on our side, not the opposite. So we started ignition at 1900 hours, and you can see a picture of the backing fire there as we started the perimeter ignition. 3 dozers, 6 engine, and a couple aircraft to help us. On-site weather was 75 degrees and 31% humidity, and a probability of ignition of 40%. And like I said, 2 days since rain, and a total of 1 inch of rain over a week period. Okay, you can take a look at this aerial shot. You can see the blackened fuel break right next to the subdivision and the perimeter ignition underway before we ran crown fire through the main block. And we initiated the crown fire at 8:45 p.m. From the southern portion of the unit, and the fire ran to the north and consumed that 50 acres in approximately 5 minutes. The weather at the time was 68 degrees, RH was 47%, and winds were light out of the south-southwest. And flame lengths peaked on that well over 100 feet. So you had a full-on crown fire at 47% humidity. So one of the things that brings up is, many will say, well, we need humidities in the 20s to make sure we get the effects we want. That's probably true in some cases, and it's probably not true in other cases. Okay, we're going to switch gears now and talk about facilitated learning analyses. And you'll see at the top there is a website that will take you to the guide on how to do an FLA. FLAs are basically used to replace a review or an investigation. It's a way to look at an event and get people to tell their story so people can learn from it, and it's meant to eliminate, the investigative or negativity that can cause people not to want to tell their story. And so we did an FLA on the Foss Lake escapes prescribed fire on the Superior National Forest this past spring. And you'll see a quote from the Chief of the Forest Service there. It says, Tom Tidwell considers learning from the events to be a Forest Service core value, both equally fundamental to prevention and critical to our safety. So this type of learning tool, is one that we hope and intend to use much more frequently within the Forest Service and hopefully throughout the wildland firefighting agencies to learn from events and have people willing to share their experiences, because, as we said at the beginning of this presentation, people will make mistakes. It's guaranteed. It's just human nature. So there's a spectrum of FLAs. Most are probably very familiar with a quick after-action review, and they kind of go up a gradient from rapid lesson sharing, which might be a 1 or 2 page document, to basic or complex FLAs that can be many page documents that go into depth on something that occurred that we have the opportunity to learn from. And down at the bottom, there's a YouTube video that gives you an overview of the FLA process and what you need to do to have a successful FLA. So I'm going to talk a little bit about the Foss Lake Fire. I'm not going to talk a lot about it because I think it's more important for folks to get a hold of this FLA and go through it. It might take you an hour, but it's well worth it. So all I'm going to do is give you a taste for this. But there's many lessons to be learned, and everyone will learn different things when they look at these products. So I'm not going to bias you any more than necessary because you'll do it to yourself. So on May 19th, 2016, the Superior National Forest was trying to implement a 78-acre prescribed fire unit. And during the course of that, the fire did escape and ended up being a 936-acre wildfire. We initiated an FLA process so that we could learn from the event, and the site is listed below. It's on the Lessons Learned website where you can find this document, so I encourage you to take a look. But I'll give you some very simple basics on this event here, and should see the map on your screen. And let me get my pointer going here. Okay, you can see the burn unit right there. And down here, you can orientate yourself. This is in the Arrowhead of Minnesota. You can see the town of Ely right there, and the burn unit was just to the west. And it was immediately up against the Boundary Waters canoe area. So the burn was outside of wilderness, but if you went north out of the burn unit, you were in the wilderness. You did have urban interface scattered all through here by Burnside Lake. And of course, the fire did escape and go into the Boundary Waters canoe area almost exclusively. So the fire ended up in wilderness. Like I said, no structures lost, no private property burned, no injuries of any magnitude. So this was just an escape. All right, so we're going to talk about how did this one play out, and is it really any different than any of the others we looked at earlier in the webinar. And a couple questions asked. Is your burn block strong? And you need to ask that in the planning stage. The burn boss needs to ask it before they accept the assignment. Can the thing be implemented? And who's watching all the weather and fuels data? There's a ton of it out there, but who's actually watching that? It's really, really critical. So we'll take a look at some of the factors that combined on this particular event. As with many, there was a desire to implement. There was it was not a large burn, and in fact, this one is the same size as the average of all the escapes we looked at earlier in the webinar. 78 acres, and the average was 77 acres. But Complicating that a bit were a couple other factors. The forest wanted a moderate to high intensity fire behavior prescription. So they did want to put heat into this unit to meet their resource objectives. And just to the north in the wilderness area, there was blowdown fuels, I believe from the 1999 blowdown. So you had a fairly difficult task here given the intensity of fire and the smaller unit size and being butted right up against the wilderness boundary. So some other conditions, the area did have drought that had onset during the spring. And another thing, there had been rain 4 days prior. So you had a couple different factors playing as the forest went to implement this prescribed burn. Again, a common denominator was ignition occurred around 11:50 in the morning, so right at the beginning of the burn period. And typical of afternoon onset is the winds increased, and they did get some spotting as they were doing the initial ignition on this fire. And they did get one spot fire. There's about 100 yards to the north in the wilderness area in some blowdown fuels. A little bit of weather data for you. The on-site weather on their prescribed burn was 30%, and their prescription was 25%. So they were in prescription with their on-site weather. However, there were off-site RAWS stations that were reading humidities already in the low 20s. So you definitely had some dryness in the area during the time of ignition. So as normal, they attacked the spot fire. However, here come the problems that really start to add up. 2 successive pumps were installed to put a hose lay in to work that flop over or spot, and both pumps would not work. They both failed, and that spot fire continued to grow. And you add all that up, and you have only a little over 2 hours from where you went to, everything seemed to be in place. They had the resources they needed to implement that burn. They felt they were within prescription, and within 2 hours, it did not go as planned. And at 14:07, the burn boss declared a wildfire, which was the appropriate thing to do. And so, when you look at Foss Lake, it's not very different from really any of the other escapes. It follows many of the common denominators that have caught us in the past. Okay, so we're going to switch a little bit to pre-mortems, and pre-mortem is essentially where you attack your plan. You want to kill your plan right at the very beginning and see what is not working with it, because you don't want to go down the road of approving or making a decision or approving a plan that really has weaknesses in it. So there's a website here. There's 7 videos that you can take a look at. It's a Forest Service website that will really run you through the process of developing pre-mortems and how to pressure test the thought or the plan that you have before you try to implement it. And one of the big things you need to look at when you do this, don't just ask yourselves how your prescribed fire could fail. You really need to ask other people. You need to get other folks' perspectives, and that's one of the characteristics of a high reliability organization, is that you want a diversity of opinions or knowledge being brought into whatever task you have. So ask others, and not just about how to hold the fire, but what about potential for injury? Are we locating our fire line in a snag patch? Vehicle accidents. Are we using, main roads that might be great fire lines, but how are we going to handle vehicle traffic? Smoke or aviation issues. So have folks take a look at your project that aren't involved in your project. You definitely want to make sure that they're objective, because anyone who has a project, you're not objective, you're biased. You have that desire to implement it and make it successful, but that can blind you to certain things. And others who don't have buy-in to it won't have that bias. One of the other things to do is use people who do not have firefighting or fire control experience or prescribed fire experience. And the reason you do that is for a firefighter, a spot fire is not really a big deal. They see spot fires all the time. That in and of itself may not cause concern to a firefighter. However, someone who doesn't fight fire, a spot fire to them might put them in a panic. And that's okay to have that perspective on the planning stage of, what are they seeing that may not be right or could end up being a problem for you or your people. Having your cooperators look at your project is really important. They may be helping you with it. And if there's an escape prescribed fire, you could affect them for years to come. If you lose a prescribed fire, well, the cooperators next door, the public doesn't know the difference. They're just afraid of prescribed fires at that point. So something real important to involve in the planning process. And another tip is maybe find your strongest critic, could be from the public, and let them take a look at your prescribed fire project. Hear what they have to say about it. Now, some of it may not be relevant, and you've dealt with it, but you never know what you're going to find. There's something, if you miss something, they'll help you find it. Okay, so some pre-mortem pressure tests. Run greater than expected fire behavior or winds or fuel moistures or drought on your project. See what happens. Run an incident within an incident. Even if everything's going right on your burn, what if one of your overhead goes down with an injury or an illness, or some other event occurs that really has nothing to do with your prescribed fire, but it's going to drain resources away from your prescribed fire in order to deal with it. So field simulations or sand table simulations also can really help try to detect the weaknesses in your project, which of course, if you can either eliminate or mitigate those weaknesses, you'll have a stronger project by the time you sign off on it or implement it. And with that, that's a lot said, so I will stop and hand it back to Jack and answer any questions if folks have them.
All right, Steve, thank you much. So yeah, folks, you got any questions, start typing them in the chat box. A couple folks have already asked if this webinar is available. Yes, it's being recorded, and I put the link up in the chat box where the webinar recording will be, and there is already a PDF of the presentation that's on that webpage.
Okay, great. Thanks, Jack.
Sure. See if we have any questions coming in here. Hang out a few minutes. And I think you stumped people, Steve.
It could be.
Or they're really considering it. It looked like some people were starting to type. Some of the private chats that we've seen, Steve, folks are saying, gee, this would be a great webinar to kind of show at the start of a burn season before people start burning, or at the start of any training exercises, as kind of a reminder to not get caught. Catch yourself in the trap.
Okay, now when I can answer these on the audio, right? I don't have to type my answer to them?
Correct, yep. So if you want to read them out, or I can read them out and then give your answer.
Okay, well, I see first, Claire, thank you, I appreciate it. And from Camp Ripley, Minnesota, the question was, what was the public comment criticism to burning in the Mack Lake area again? We successfully fought the 2012 Little Mack Lake Fire, so, we really had some positive public impressions of the Forest Service when we went to implement that burn. So it was about 50-50. Half the people in that subdivision said we're crazy and we're going to burn them out of their homes again, and the other half said, you know what, they did a great job stopping the wildfire. It ran into the fuel breaks that were there, and we trust them, and we support them. And so it was somewhat average for the type of resistance you would think you would get for a project like that. So from my perspective, given the history from the Mack Lake Fire, we had pretty good support given the history.
Looks like we got some folks typing in more. There you go. So Walt asked, do we document when prescribed fires are not initiated for the reasons you mentioned?
Okay, and that's a great question, and we don't have good systems in place to document when we're making those types of decisions, and that's one of the reasons that we're still working on developing a learning culture, certainly in the Forest Service, because that's a success story. You know, when someone detects problems that they say, look, things just aren't lining up, it's good to share that. Or when they shut a burn down midstream and say, look, we're just, you know, we see things developing in a way that could be problematic. Those are what we call near misses, and we can share those on the Lessons Learned website, but it's not really a culture yet to do that as frequently as I would like. So it's very sporadic how we're sharing information, but that is critical information. Good question, Walt. Okay, I see someone else typing there.
Yep, we'll give them some chance. I'm going to get a link up. Steve gave a webinar for the Lake States October 2014, I believe, and that had to do specifically with the Maple Ridge prescribed burn. So I will get that.
Right. Yeah, there's a lot more detail on that webinar that's specific to the Maple Ridge burn. So for those interested in that, especially Camp Ripley, Minnesota, check that link out that Jack's working on. Okay, that's a great question, and in fact, that's exactly what I did on the Huron-Manistee during my tenure there. It was clear that the potential for escape of our prescribed fires in the spring was very high, and so we did switch some of our burning, particularly in red pine and even in jack pine. We switched some of our burning to the summer, and it has continued to be successful. And I would agree that there's less chance of escape. You have a green component in your understory fuels, and your live fuel moisture in your canopy, and those pine forest types is much higher. And so I would really recommend that folks look at summer burning in some situations. So no, they do not deter me from recommending summertime burns. I would recommend them. Not in all cases, but I think the summer burn is underutilized significantly in the Lake States.
And I'm glad you mentioned that with the seasonality of burning. There's been a lot more discussion about that, of kind of opening up the burn window across the season. So you're looking at both dormant season and summer burning, both for ecological effects, but like you said, in the case of jack pine, you can kind of reduce that risk because you're kind of out of that explosive spring dip period.
Yeah, you just don't have the spotting potential, and you really have a drag on your fire behavior. That fire has to work its way through green understory components, and it just does not have the same horsepower as a spring burn, where when you're dry, the fire behavior is unrestrained. You saw it on the Mack Lake Fire, where you drop the match and you got an unrestrained energy output.
Definitely. Well, we'll give just a couple more minutes, see if we get any more questions coming in. People can type them in. And while we're waiting, what I'll do is go ahead and just set up or introduce next month's webinar. So you get that up on the screen now. So we're going to have a webinar from Donald Brown. It's going to look at survey and analysis design for wood turtle abundance monitoring programs. That'll be March 16th, 2017, 2 p.m. Eastern, 1 p.m. Central Time. There is a web page that's up. So if you go to Lake State's homepage, you'll find links to this webinar, how to connect. It doesn't look like we have any more questions, so we might as well wrap it up. So again, thank you so much, Steve, and for everybody online for joining us this afternoon. Again, I will get a recording, a link to the recording up on the web page. Should be within the next hour. And there's a PDF of the presentation that's already up on the web page. So that's pretty much it, unless, Steve, if you have any last words for us.
Okay, no, I don't. Lots of thank yous there, and so I just want to say thank you, Jack, and to all the folks who bothered to spend an hour here taking a look at this and listening. Sure appreciate it.
All right. Thanks, Steve.
Okay, talk to you later, Jack. Bye.